Radiation or other unforgiving circumstances would see problems arise with blowing up everything we assumed we knew about where life can exist. It could show us that we can figure out how to flourish even in places that appear difficult to us. However, of course, it's not generally as natural as it sounds. Finding life on another planet, particularly one as distant and unique as Proxima B, is a tremendous test. Researchers should utilize all their abilities and the most trend-setting innovations to reveal the secrets of this far-off world and its true potential for life. How might we go to Proxima B? The hypothetical idea of exploring distant planets like Proxima B is quite extreme due to some significant challenges. Right now, our telescopes, like the James Webb Space Telescope, are invigoratingly providing us with a glimpse into these faraway worlds. However, they can't give us very clear pictures or allow us to do active investigations because these planets are far too distant. To overcome these challenges, we need to improve our telescopes and sensors, and perhaps find new ways to traverse space. Suppose we could develop new types of engines that could take us to other star systems much faster than we can now. This would open up a totally different realm of exploration and discovery. Researchers are already investigating several exciting concepts, like solar sails that use sunlight to push spacecraft or ion drives that shoot out particles to propel ahead. There's even talk about warp drives, like in sci-fi, that could bend space to travel faster than the speed of light. However, these are still ideas that require much more research and testing before we can use them to explore other planets. Still, it's exciting to think about the possibilities. Perhaps one day we'll have the technology to visit places like Proxima B and uncover the mysteries they hold. Imagine having the option to go to Proxima Centauri, the nearest star system to us, and meeting extraterrestrial life. It may not be as far-fetched as it sounds. Researchers at the Breakthrough Starshot project are figuring out how to make the journey shorter, from many years to just a few decades. One major challenge is ensuring a spacecraft can continue to accelerate as it approaches the speed of light. Currently, with our existing technology, it would still take about 6,000 years to reach Alpha Centauri, the star system that includes Proxima Centauri. The Starshot project has an exciting plan to use lasers to push a spacecraft toward Alpha Centauri. However, here's the tricky part: Earth's atmosphere can interfere with the lasers, making it hard to give the spacecraft the right boost. Bandatunga, the lead researcher, believes we can use a special technology called adaptive optics to fix this. Small lasers on satellites would continuously check the atmosphere, helping larger lasers on the ground stay focused on the spacecraft. These lasers need a lot of power, like all the electricity used in the entire US, but they only need to be incredibly strong for a brief moment. They plan to use 100 million lasers spread over a vast area to propel the spacecraft on its way. Once the lasers are switched off, the spacecraft will zoom through space at an astonishing 20% of the speed of light. It would be around 10 meters wide and could reach Alpha Centauri in just 22 years. That's quicker than many people's lifetimes. When a spacecraft reaches Alpha Centauri, it faces several major challenges. First, the gravity of the Sun and debris in space could slow it down significantly. Even if it reaches Alpha Centauri, it would take another 4 years for its messages to arrive on Earth. That's like sending a letter and waiting years for a response. Researchers like Bandatunga and others are striving to ensure the spacecraft doesn't melt on its journey. They want to make the craft's surface nearly perfect at reflecting light. They also need to ensure the spacecraft heads in the right direction and slows down quickly to avoid overheating. One of the most intriguing aspects of this plan is that once they figure out how to launch one spacecraft, they can send more at a reasonable cost. This means they could explore many star systems and increase the chances of finding Earth-like planets. Just imagine the possibilities if we reach Proxima Centauri. We will have an entirely new star system to explore. Who knows how many planets like our own might be out there waiting to be discovered? Researchers have already found thousands of exoplanets, planets outside our solar system. They made their first official discoveries in 1992, finding planets around a unique type of star called a pulsar. 3 years later, they found a planet orbiting a star similar to our Sun. Since then, they've discovered many more planets, including some comparable in size to Earth and located in the Goldilocks zone of their stars, where conditions are just right for life. It's an exciting time for space exploration, and you can't help but be captivated by how the JWST made its discoveries. How did the JWST make these discoveries? The James Webb Space Telescope is like the superhero of space instruments, positioned at a spot called the second Lagrange point, or L2, which is about 1.5 million kilometers away from Earth. This positioning helps the JWST maintain a stable orbit as Earth moves around the Sun. Outfitted with all kinds of extraordinary apparatuses, the JWST is intended to reveal the universe's most profound secrets and solve its greatest mysteries. One of its primary roles is to hunt for exoplanets, planets outside our solar system, and check whether any of them are like Earth. You know what's particularly interesting? It's going to investigate Proxima B, that mysterious planet we've been discussing. The JWST can take pictures and gather data using various types of light, especially infrared light, which resembles a secret code that helps us see things that regular light can't. Its main mirror is comprised of 18 hexagon-shaped segments and is an incredible 6.5 meters wide, taller than two adults standing on top of each other. This huge mirror helps the JWST take extraordinarily clear pictures of exoplanets like Proxima B, far better than any telescope before it. These fascinating features of the telescope assisted in seeing things that are far away and incredibly faint. Imagine trying to see a firefly glowing in the dark from a great distance. The size of the telescope's mirrors is crucial because it helps gather even the tiniest bits of light. This makes the telescope much better at seeing things in space, like the first stars and galaxies that ever existed, or even the faint flashes bouncing off exoplanets. The James Webb Space Telescope is capturing these bits of light and assembling them to create a clear image. However, here's the thing about exoplanets: unlike stars that shine on their own, they're more like mirrors that reflect the light from their stars. They're so small compared to the vastness of space that they look like tiny dots, just like stars do when you gaze at the night sky. We wouldn't even know these exoplanets exist if it weren't for two distinct phenomena. First, when they pass in front of their stars, they make the stars appear a bit dimmer for a brief moment, like a mini eclipse in space. Second, they pull on their stars just a little with their gravity, causing the stars to wobble slightly in their orbits. It's like a vast dance between the planet and its star, and we can observe this interaction thanks to telescopes like Kepler, which has been working to spot these wobbles and many eclipses. It has found numerous exoplanets during its time in space. Up to this point, we haven't been able to explore the area around Proxima B, that enigmatic planet we've been discussing. But guess what? Now, with the JWST, we're about to change all that. The JWST is like a superhuman telescope with 4 magnificent instruments: a near-infrared camera, NIR-CAM, a near-infrared spectrograph, NIR-SPEC, a near-infrared instrument, NIRIS, and a mid-infrared instrument, MIRI. These devices will help us see things in space more than ever. They can detect light from all over the cosmos, even from far away or dim spots in space. And here's the intriguing part: they can even see different wavelengths of light, from those visible to the naked eye to those we can't see, like infrared light. This unique light can help us figure out what's in the atmosphere around exoplanets like Proxima B. We could even find hints that tell us if there's water or oxygen there. NIR-CAM is like the main camera of the JWST and is perfect for observing what happens when a planet like Proxima B passes in front of its star. It's like taking a picture when a bird flies before the sun. This camera can help us learn about the atmosphere of Proxima B and how it may differ from Earth's. NIR-SPEC is an amazing tool because it can split light into different colors, like a rainbow. By examining these colors, scientists can determine what a substance is made of, how hot it is, and other vital information. This will be valuable for studying the atmosphere around Proxima B and searching for signs of anything happening beneath the surface. MIRI, on the other hand, can detect light that is a little warmer than what other instruments can see. It's like having a special heat vision power. You won't believe this, MIRI could even potentially detect signs of artificial light coming from Proxima B, like finding a secret message in the stars. While MIRI may not be able to spot a single light shining in an alien's home or the bright lights of bustling cities, it is still an incredible tool. When you combine MIRI with other instruments on the JWST and its enormous mirror that gathers lots of light, you get an amazing telescope. When we combine all the fantastic instruments on the JWST with its massive mirror, which collects a vast amount of light, it becomes an extraordinary telescope. It can see small details on exoplanets like Proxima B and perhaps find faint signs of artificial lights or other hints that intelligent life may exist out there. This is a monumental leap forward in our quest to determine whether we are alone in the universe, another milestone in humanity's journey of discovery. Proxima B is like a stepping stone that helps us learn more about distant planets. It's a small step that opens up huge possibilities for exploring the universe. But Proxima B is just one piece of the puzzle. There are many types of exoplanets out there, each with its unique features and potential for life. Some exoplanets are like giant balls of gas, like our hot Jupiters. Others are rocky, like Earth or Mars. There are even super-Earths, which are larger than our planet but smaller than Neptune. Each of these planets offers a different glimpse into the variety of worlds beyond our solar system. Telescopes like Kepler and the JWST have been vital in this exploration. Kepler has identified thousands of potential exoplanets, giving us a glimpse of the diversity of planets out there. The JWST, with its advanced technology, has taken us much further by helping us understand the atmospheres and compositions of exoplanets. Proxima B, on account of these telescopes, has allowed us to learn about how planets form and the conditions that could support life, as well as the diversity of planetary systems across the universe. This information isn't just fascinating, it's also significant for guiding future space exploration and expanding our understanding of the universe beyond exoplanets. The James Webb Space Telescope, JWST, has made other exciting discoveries, helping us observe distant galaxies in their early phases and giving us insights into how galaxies form and evolve. It has also shown us more about how stars are born and how galaxies come together, enhancing our understanding of the vast universe around us. The JWST has the ability to amaze, enabling us to see far into the universe, revealing things we could only dream of seeing before. It can peer through cosmic dust clouds and capture the faint light from stars that are billions of years old. With this remarkable telescope, researchers can learn about how planets form, what the atmospheres of different planets are like, and even how black holes behave in incredibly distant galaxies. By utilizing the JWST, scientists have not only found answers to questions they previously had but have also discovered new things to ponder. This telescope is like a window into the universe, giving us a deeper understanding of space and everything in it. In the future, the JWST will help us learn even more about the origins of the universe, showing us how galaxies formed and providing more clues about how life could have begun. It will also assist us in studying planets outside our solar system, called exoplanets, and exploring worlds that are so far away we can scarcely see them. One of the most intriguing possibilities is that we could soon find life on another planet, like Proxima B. If we do, it will change everything we know about our place in the universe. Discovering life on another planet would demonstrate that life isn't just a unique phenomenon to Earth, but something that could exist elsewhere in the universe. This revelation would lead to exciting advancements in science, helping us learn more about life, where it comes from, and how diverse it can be throughout the universe. Finding life on a planet like Proxima B would be an incredible milestone in humanity's history, prompting us to reflect on our position in the universe. We might begin to reconsider what it means to be human and how we interact with different forms of life. This discovery could also spark discussions about our responsibilities to other beings in the universe. Additionally, finding life on Proxima B could influence how we think about art, literature, and media. We may see new stories and ideas about space exploration and our role in a larger universe, inspiring children to pursue careers in science, technology, engineering, and mathematics, STEM. However, finding life on Proxima B would also raise significant questions. We would need to think carefully about how we interact with this new life and the impact we may have on them. This would require us to consider the consequences of our actions and how they could affect both our civilization and theirs. The discoveries made through the James Webb Space Telescope have opened up new horizons in our understanding of the universe. We have learned about the birth of stars, explored distant worlds, and unveiled the mysteries of planets beyond our solar system. This telescope has been like a window into the vastness of space, revealing things we never knew. The impact of the James Webb Space Telescope on our exploration of the universe is tremendous. It has helped us learn more about planets like Proxima B and allowed us to study ancient worlds. Its discoveries have advanced our knowledge of the universe in ways we could never have imagined.